Hello, my dear students, and welcome in the Indoor Environmental Control course. I am Associate Professor Kareem Galal. The title of this lecture is Vision. First we will start with the eye and brain. Light is perceived by the eye. Its diagrammatic section can be compared to a camera. Aperture, controlled by a light meter, the pupil, the size of which is varied by the iris, and controlled by the retina, which is the eye's main adaptation mechanism. Focusing, controlled by a coupled rangefinder, changing the shape of the lens by the ciliary muscles, thus varying its focal length, which is the accommodation mechanism. The adaptability of the retina can only be likened to using films of different speed or ISO rating. The retina incorporates two kinds of nerve endings, cones and rods. A normal eye has some 6.5 million cones, in and around the fovea, which are sensitive to both quantity and quality, color, of light, but operate only in good lighting, photopic vision. The retina also has some 125 million rods, which are more sensitive than the cones, and which perceive only quantity of light, but do not distinguish color, scotopic vision. Without light, there is no vision, but visual perception depends as much on the brain as on the eye. It is largely dependent on recognition. Life is continuous learning, quickest at the cradle and gradually slowing. New visual images are compared to and built into relationships with images already stored and with percepts from other senses. To enhance the visual performance, there are lighting requirements. We can classify them into two groups: quantitative and qualitative requirements. Let's start with the quantitative requirements. The contrast sensitivity of the eye is very good in good lighting. In full daylight, a luminance difference between surfaces as little as 1% can be distinguished, but under poor lighting conditions, surfaces with up to 10% luminance difference may be perceived as equal. Contrast is expressed as the ratio of luminance difference to the lower of the two luminances. Find formula on the left. Visual acuity: same as with contrast sensitivity, the law of diminishing returns applies. A small increase at a low level of illuminance produces a large improvement in acuity, but a similar increase at a higher level of illuminance is barely noticeable. Visual performance is a function of time that is required to see an object, or of the number of items perceived in unit time. The time required to perform a certain visual task decreases with the increase of illuminance. The adequacy of lighting is a quantitative requirement, which depends on the visual task, the contrast, the fineness of detail, and the speed at which the view changes. To set the required lighting level, the risk of possible errors must be judged and balanced against the affordability of lighting. As visual efficiency of people reduces with age, it is advisable to provide better illuminance for older people. Recommended or prescribed illuminance values also depend on socio-cultural, as well as economic factors. The suitability of lighting is a qualitative requirement and has at least 4 component factors. 1. Color appearance and color rendering. Adequacy. 2. Color appearance of an environment is associated with mood and the expected atmosphere. These are psychological and aesthetic effects. For example, one does not want 2000 lux illuminance of a blue-white color in an intimate restaurant. 3. Directionality of light must suit the functional as well as the psychological requirements of a visual task. A more diffuse light is normally judged as more pleasant, but it will cast little or no shadows, so it may create a hazy or even an eerie atmosphere. 4. Glare should be avoided, but the extent of acceptable glare must suit the visual task. But sometimes we exaggerate the amount of light used, which causes glare. What can we do? Glare is caused by contrast, and if the luminance ratio, L maximum over L minimum, within a visual field is greater than about 15, some sources suggest 10. Saturation glare can be caused when the average luminance of the field of vision is in excess of 25,000 CD per meter square, 80,000 ASB. The eye, both the pupil and the retina, adapts to the average luminance of the visual field. While driving at night, this average luminance is quite low, even when the high beam of headlights illuminates part of it. So, much of the visual purple is removed from the retina and the pupil is wide open. An oncoming car traveling with high beam on can cause disability glare as the pupil closes down to minimum in a few seconds. So only the headlights are visible, not the rest of the field. Such disability glare can normally be avoided, but discomfort glare is more of a problem. Thanks for following me and hope that I have explained the topic well. This material is copyrighted. Associate Professor Kareem Galal 2021. All rights reserved.